It's the 2nd of June, 2015, and this is episode 218. This show is intended for informational and educational purposes only. What cryptocurrency enables is new, empowering, and exciting, but we're not experts. Just obsessed companions walking the road towards a more peer-to-peer future.
Hi, and welcome to Let's Talk Bitcoin. This is Matthew Zipkin, and today on the show, our guest is Chris Pacia. He's developed a decentralized communication system called Subspace. How are you doing today, Chris?
I'm pretty good. Thanks for having me.
Cool. Thanks for joining us. So tell us a little bit about Subspace. What is the problem, and how are you solving it with this new protocol?
Okay, well, the general idea here is to create a lightweight, peer-to-peer, somewhat anonymous communication protocol. I originally got interested in the idea. This goes back to an article written by Mike Hearn sometime in the mid last year, where he talked about creating a store and forward network that could be used by Bitcoin wallets. His primary use case was thinking in terms of like BIP70 payment requests, where a wallet could send a payment request to another one over this network. Recipient's wallet, it could send the payment back over that same channel to the recipient. So rather than broadcasting the payment to the Bitcoin network. And I think that's certainly a good use case for it. I think there are others, but it kind of got me thinking, if we had a sort of a generic communication channel that we could use for Bitcoin wallets, there'd be quite a few things that we could use this for. So I kind of started jotting down some designs for how we might go about doing it. I kind of started a little bit with Mike Hearn's idea, and I've kind of moved from that a little bit. But, the underlying idea is the same, that we would have a communication channel that wallets could use to talk to each other and send generic messages. If we start to think about what we would like such a communication channel to look like, we would want it to be able to store messages so that the recipient could retrieve it later on, especially if we're talking about payment requests and what have you. We would like it to be scalable. We'd like it to be preferably not that difficult to implement. And at least from my perspective, I have a pretty strong privacy focus. I'd like it to be as anonymous as we can get it. We'd like to go farther than just sort of encrypting the data and to the extent that we can, hide the metadata. And if you go around and you start looking for messaging protocols, there's quite a few out there. You have a really large number to choose from, but there are not a whole lot of protocols that sort of meet all of those criteria. The one that I think people think of the most is BitMessage, and I like BitMessage a lot. I think it does a good job of providing private communications, but it's a bit of a heavyweight protocol. It has some scaling issues that potentially could be addressed. And the big thing is it's using this proof of work as a sort of an anti-flooding mechanism or anti-spam mechanism that kind of prevents you from sending messages back and forth to each other in real time. So you can think of some use cases where you might want to have that ability. And with BitMessage, you might have to wait anywhere from 30 seconds to 2 minutes. So all that kind of, after you sort of examine the landscape, I was kind of left with, well, there aren't a whole lot of protocols out there that kind of would fit the bill. So I started jotting down some designs for one and, got some feedback for some other people. I've been working on kind of coding this up and putting it out there. So once I have the code written, I hope I can get some more feedback from people.
Does BitMessage have its own blockchain?
No, it's just a generic protocol. But what happens is every message it uses like packet flooding, like in Bitcoin. They go out to every node, and every node stores every message in the network. So you can see it creates a pretty big burden on nodes in the network, depending on how many messages are in the network. You have to store all of them.
Right, because you don't want to be offline when a message is coming through, so somebody needs to sort of back it up for you.
Yeah, exactly. And then you have to basically download all of them and attempt to decrypt all of them, which is kind of resource intensive as well.
Right, and then only the ones that do actually decrypt were obviously the ones that were intended for you.
Yeah, I'm kind of doing the same thing in Subspace, but you're only going to be downloading a fraction of the overall messages, not the entire message space. And each node would only be storing a fraction of the overall message space.
One last question about BitMessage. Is there a Bitcoin reward or some type of like mining token for the nodes that participate?
No, not at the moment.
Okay, so that one's totally volunteer and you're relying on the philanthropy of the users. Okay. And then, so the other thing you mentioned is BIP70, which is the payment protocol. Let's talk a little bit about that as sort of like the current legacy system. Can you give us a little summary of how BIP70 works?
Yeah, so a lot of people don't know this, but the original Bitcoin client 0.1, Satoshi included an option where you could send a payment to someone to their IP address. And the way this would work is you would enter someone's IP address, not their Bitcoin address, just their IP address. Your client would then go out and make a connection to their client. The recipient would then send you a fresh Bitcoin address, and then you would basically send the payment back to them over that channel, and the recipient would broadcast it. Now, Satoshi kind of envisioned this as sort of the primary way that people would pay, and just sort of broadcasting a message or a payment to the Bitcoin network to someone's Bitcoin address was sort of as a backup in case people weren't online. I mean, it works, but then you have, there are issues where, people are behind the net.
Sure. Anyone on your local Wi-Fi would technically be on the same IP address, right? From the outside world's perspective.
Yeah, you have issues with NAT traversal. There's also, not everyone keeps their clients online all the time. So it's just sending to a Bitcoin address and just broadcasting the payment to the Bitcoin network directly just kind of became the default way. And eventually they just removed the pay to IP from the client.
Yeah, it's an interesting little piece of history there. So even in the send to IP model, there is still a blockchain, right? Somebody still has to put that transaction into a block.
Yeah, and the way it worked is the recipient would have broadcast it to the Bitcoin network, and then the nodes in the network would have collected it and organized it, into the blockchain. So the original idea, going back to BIP70, the way the BIP70 payment protocol works now, it actually works sort of similar to that, in that when you click on a Bitcoin URI or you scan a QR code with a merchant, that your client will make a direct connection to the merchant's server, exactly the same as that original protocol. And just in this case, it's using the X509 certificates. And it would download a new payment request that has a new Bitcoin address in it, and then it would send the payment, push the payment back to the merchant server. And it works pretty well from a merchant perspective, but we don't have any way currently of doing the same sort of thing on an individual level. And so that's kind of where, Mike, with this idea of a store and forward network, that's kind of the direction he was trying to go in, where you could extend the same functionality that we currently have with merchants with the BIP70 payment protocol. We could kind of extend that to individuals, but they wouldn't have to run their own server. This would all be part of this store and forward network.
I see. So you mentioned the X509 certificate. That's the magic behind BIP70, right? The idea is that instead of just seeing a Bitcoin address on a website, it's actually signed the same way an HTTPS website is signed by a certificate, right?
Yeah, it's using the same type of technology for authenticating the payment request so that you know that it actually came from the company that you're sending coins to.
And then the nice thing is about BIP70 is that instead of just securely downloading this one Bitcoin address, you can download all this, any kind of other information you want in there, like a refund address and all kinds of other stuff that the wallet just parses.
Yeah, you could have that. You can also attach messages to the payment requests or to the payment as well. So like if I sent you a payment, I could attach some kind of note that, from me to you. Whereas right now, we don't have any kind of way of doing that on an individual basis, I should say. I mean, some people might try to put data buried into the Bitcoin blockchain, but it's public information for anyone to see. But if you have sort of a separate private communication channel, then I could attach, any data to that message I want.
Actually, I don't think I knew that about BIP70. I thought BIP70 was sort of a one-way, you download a payment file from, say, Coinbase. But are you saying that part of BIP70 is also a message that you send back to the merchant?
Yeah, you have the option of sending it back to the merchant or just broadcasting it to the network. I believe most people, the default is to send the payment back to the merchant and the merchant broadcasts it.
Okay, interesting. And in that case, you can also add whatever else you want, like a shipping address or a personal message or something.
Yep.
Okay, cool. So that takes us to Subspace. So what's wrong with BIP70 and BitMessage that you're fixing with Subspace?
I wouldn't say there's anything wrong with BIP70. It's just we'd like to be able to use it on an individual level from person to person rather than just person to merchant. And of course, that requires some kind of communication channel between wallets. And I've already kind of mentioned some of the drawbacks of BitMessage. We could really use anything. I think I've seen a proposal from Electrum to use just basic email, SMTP. for kind of doing something similar. But I'm looking to kind of, we have the technology available to do this in a way that's, lightweight yet still scalable. So that's kind of what I'm trying to do. Part of this whole Mike Hearn's kind of proposal, this was in sort of the concept of stealth addresses as well, which are just like a single Bitcoin address that you can publish, and the sender's wallet would calculate a new address where the payment would be sent to. And if you have this other communication channel, it ends up making quote unquote stealth payments a lot easier, because you can just send the extra data that you need to do this stealth address or these stealth transactions over this other communication channel. So you can imagine people can then just sort of publish a single Bitcoin address and receive payments there. You could also push a payment request to that same address, using the same communication channel. So you could end up seeing things like merchants could push a payment request to your wallet to bill you for, let's say, monthly services, right? So right now, we don't have any way where merchants can really send you a monthly bill, or at least they can send you a monthly bill in like email or something, but then you have to kind of manually pay them. But this is a way where they could push it to your wallet and you would just have to click approve. So we can think of a whole bunch of things that we could do if we had this kind of communication channel, this sort of link between wallets.
That's interesting that you mentioned the stealth addresses, because the way it currently works, if you're using a stealth address, basically the sender needs to include some entropy in an op return. And then on the receiver end, every time you see an op return, you sort of need to check, is this for me? Is this my stealth address? And if it decrypts correctly, then you know it's for you. But that's processor intensive and is also blockchain bloat sort of, risky.
Yeah. And then you could just, instead of putting that in the blockchain, that data, you could just send it over this other communication channel.
Okay, cool. And also there's a privacy element here too, right? Because if you're running a light client, you need to sort of query full nodes about your own balance, which is a potential privacy leak. So you can sort of use this to know that you've been paid without having to ask full nodes.
Yeah, that's exactly it. In fact, that's kind of what got me into this. So I do some work in Java and use the Bitcoin J library, which is the primary library which implements the Bloom filters in the Bitcoin protocol. And Bloom filters are used, or at least we try to use them as a way that we can, instead of just handing over to the nodes that are basically serving us our transactions, instead of handing them a list of all of our Bitcoin addresses, which would just basically be blowing our privacy, we instead hand them a Bloom filter, which is like a data structure that they test transactions in the blockchain against. And if you get a match on the Bloom filter, they send it to you. But the way it works is that some transactions that don't belong to you will match your Bloom filter. So they end up sending you more transactions that actually belong in your wallet, but then they don't know which ones actually do belong in your wallet. Or at least that's the general idea. In practice, however, there's quite a few privacy leaks associated with Bloom filters. I could spend an hour just going over all of them, but there's quite a few of them. And I've spent a bit of time trying to fix these privacy leaks in Bitcoin J, sort of somewhat unsuccessfully. It was like every time I fixed one, I created another one. And I kind of came to the conclusion that there's really no real way to use Bloom filters or prefix filters, which is another filtering scheme that's similar, to do that without creating privacy leaks in at least some situations. But if you can push the transaction to the recipient, send it to the recipient over another channel, and then the recipient just has to upload it to the network, you avoid having to download your transactions. And so you can essentially avoid that sort of privacy leak associated with the network level data.
Got it. So the first thing that pops into my mind here is, what if the buyer attempts to double spend the output he just sent you and broadcasts his transaction to the network before you have a chance to broadcast yours?
We would probably have to do more work on our end to figure out if the transaction's valid. It would probably entail creating a one-time Bloom filter that just contains that transaction ID that we're interested in. And we would give it to a couple of our peers, and then we'd probably broadcast the transaction to the rest of our peers, and then wait to see if those peers that we gave our filter to relayed it back to us. And if they did, we could treat it as a valid transaction. And we'd probably have to use the same sort of process for querying for block inclusion to see if the transaction made it into the blockchain. Those peers that have that filter would then send us the next block with the Merkle proofs when it comes in. Doing it this way would just be done as like a one-off. So if we were interested in let's say, hiding our IP address from that node. We don't want that node to know that that particular transaction, came from us. We could just do that query over Tor. So if you had your wallet was connected over Tor, that would hide your IP address that way. I'm kind of on the second version of the protocol. I've gotten some feedback from some people. Mike Hearn's given me some good feedback. I've been talking with Manfred, who's been working on the BitSquare project, the peer-to-peer exchange. They have a need for something similar to this, the Open Bazaar guys. So these sorts of projects really kind of only gain traction if you kind of have engagement from the community. So I would say that nothing up to this point is really kind of finalized. And so if people would like to put some ideas out there, bounce some ideas off me, give me feedback, I'm certainly open to that.
So how's it work?
The basic way it works right now is you have this distributed hash table, which is like a distributed database, basically, where each node in the network stores only a portion of the messages. So if you can think of like BitMessage, where every node is storing every single message, in the Subspace network, you're only storing a small percentage of those messages. So maybe, 2%, 5%, depends on how many nodes are in the network. And when you connect to the network, when someone wants to send you a message, they would insert the message into this DHT using a key, because this is a key value database. They'd be using a key that is in the same neighborhood as your public key. And neighborhood is sort of a DHT term. It's within a certain range, basically. And then when you want to receive that message, you connect to the network using your public key as your node ID, and then you would download all the messages that are in that same range, which inevitably some of them would belong to you, some of them wouldn't. You attempt to decrypt each one. So it kind of sort of does the same sort of thing as BitMessage. It's just you're downloading fewer messages, and it kind of makes it a lot more scalable and a lot more lightweight. You're not having to sort through every single message in the network.
Doesn't this have the same privacy leak problem as Bloom filters? It's kind of false positive. You sort of blur your intent, but how is this any better than the way a Bloom filter works with the false positives?
Right. So one of the problems with Bloom filters is not necessarily the kind of design of the filtering scheme, but it's when you're trying to apply it to the Bitcoin protocol. Because you have Bitcoin transactions, they have inputs, they have outputs. Let's say you have a situation where you make a transaction that has multiple inputs in it. Each one of those inputs are going to match your Bloom filter. But the probability of having a transaction with multiple inputs matching your filter is pretty close to zero normally, right? Or at random, that really wouldn't happen. So if you come across a transaction where multiple inputs are matching the filter, it probably belongs in that filter. That's sort of one example. Another problem would be we don't want to reuse Bitcoin addresses, so we generate a new address for every transaction. Well, if you're adding that address into your filter, you have to recalculate the filter, and that creates possibility for where you can check to see where that filter overlaps with the old one, and that overlap is basically your transactions. It's more due to how we use Bitcoin than it is the actual problem with the filtering mechanism. So if we're talking about using filtering in terms of just messaging back and forth to each other, we really don't have that problem.
Okay, cool. So there's a DHT, and you ask all the nodes, do you have any messages that match my public address? Is it literally your Bitcoin public address, or is it something like cloaked?
It could be your address. You're not actually asking them, do you have any messages that match my address? You just kind of join the network using a particular node ID, and when their other nodes see that you've joined, they just forward you the messages they've been storing. So you're not really particularly requesting anything in general. They just kind of send it to you as it comes along.
And just a general question about a distributed hash table model. Does every node have the entire database, or does it at least know which other nodes to ask?
Yeah, you can figure out which other nodes have that data. The way it works out, there's a value or parameter called k-value, which is basically how many nodes a particular data is replicated in. So by default, it's usually about 20, which you can change if you need to, which means that any given message would be stored in, at minimum, 20 nodes.
Okay, and you just have the IP address of those 20 nodes so you know who to send a request to?
Yeah, when you kind of join the network, you do this sort of iterative routing query to find the nodes in your sort of neighborhood where your messages are being stored. So yeah.
And is there any kind of incentive for the nodes? Is it like BitMessage where it's volunteers, or do you think there could be some sort of Bitcoin reward for people who participate?
At the moment, I don't have anything like that in there. I do have some ideas for including a reward that hasn't been put into the code as of yet, but it's certainly something I'd like to see because disk space is a scarce resource, and so if we can ration that by price, that would certainly be better than just relying on volunteers. But of course, doing that in a way that also maintains your privacy is kind of tricky. I have some ideas I'm playing with, but I haven't written any code for that.
But we've also seen that networks with willing participants can work without compensation. I mean, I'm constantly amazed when I think about it, just that the fact that regular IP packets get passed around the internet by all these computers out there. And, I'm only paying, let's say Comcast, and still my messages are getting all the way to Japan or whatever. So, okay. So how much trust do you need to place in these nodes?
There's no trust. It's just a matter of if they're misbehaving, they just won't send you messages, but there's some redundancy built in. So even if a couple are misbehaving, you should still receive your messages.
I guess I mean not just reliability and uptime, but how do you know the message hasn't been tampered with?
There's a couple different ways. For privacy reasons, I'm less inclined to use a digital signature, and instead we can use like an HMAC using a shared secret from both the sender and recipient's key. It kind of does the same thing as a signature, but you have some repeatability. Like you can kind of deny that you actually sent the message. But it's sort of the same thing as a digital signature in that you can prove that the message hasn't been altered in transit.
So how are the messages encrypted that you store on the server?
Basically, we use your public key, the sender's public key, the recipient's private key to generate a shared secret using an algorithm called elliptic curve Diffie-Hellman. And then that shared secret is just used for standard, AES encryption.
Right. So this is, you take the merchant's public key, combine it with your own private key, and then the merchant takes his private key, combines it with your public key, and that way you have a shared secret, and you can just encrypt messages with the AES or something like that.
Yeah, that's exactly how it works. Although that doesn't have to necessarily be a merchant. It could be, anyone sending a message to someone else.
I'm surprised there isn't already more elliptic curve Diffie-Hellman applications already happening in Bitcoin. I know Next uses it to send encrypted messages right on their blockchain. I always thought that was sort of interesting. So it's cool to see that you've integrated it in what you're doing.
Yeah, definitely.
So when you get the merchant's public address, though, that would potentially be a stealth address, right?
If you're trying to make a stealth transaction, you could use that to generate a shared secret, and that could be used as what's called the chain code in BIP32 to derive a new public address for that merchant or that whoever you're sending the coins to.
And then just help me make this analog work. So in regular stealth address blockchain transactions, there's an op return with a piece of data there. And would that data have to be in plain text for this process to work?
Well, that in a normal stealth transaction, that's just a shared secret that's generated between the sender generates like an ephemeral key pair, and he uses his ephemeral private key and the recipient's public key to generate the shared secret. And that shared secret is then used in the generation of the new Bitcoin address for which to send the coins to. And then that ephemeral public key is basically what's put into the op return in the transaction.
Oh, okay. I always thought it was like a nonce, like just 32 bits of entropy, but it's actually a key.
Yeah, it's basically a public. They call it a nonce, but it's just a elliptic curve public key.
Okay, cool. It's frankly, it's so simple. I wonder why it hasn't been used before. Like this already seems simpler than Bitmessage and BIP70. What do you think? What's new here? Why did it take so long to bring this to light?
I don't know. I think people are still kind of getting the feel of distributed systems. I know they're kind of been out there a while, but it seems like there's kind of more and more use cases, and it doesn't seem to be sort of any real kind of standard implementations or anything that people have come up with yet, at least not within the Bitcoin community. It seems like everybody's kind of doing something a little bit different here or there. So we'll see. I have a number of things I'd like to do with this messaging protocol. So not just, I've already mentioned a couple. I can send a payment request from one client to another. We can push a payment directly over this channel. But we could also use it for, let's say, coin join transactions or coin shuffle, because, up to this point, one of the primary things that have been holding CoinJoin back is there hasn't been a really good communication channel for sending messages back and forth, because clients basically need some way of communicating with each other, do this CoinJoin transaction. The only ones we've really seen up to this point have sort of been server-based, right? That where the CoinJoin transaction just takes place on a particular server.
Right. You've either got like the dark wallet obelisk server or blockchain info or DashPay. Darkcoin has got their master nodes.
Yeah. So if you have, wallets connected in a network, you can potentially make this happen if they're already having a communication channel that they can send data back and forth to each other.
So in the case of a coin join, you would sort of post a message to the network and it wouldn't be encrypted because you want everybody in on it, right? And everybody would just see that there's a new coin join going on and they could communicate with each other and finalize a transaction that way.
Yeah, it would. Yeah, exactly like that. You could even, just for privacy purposes, you still could encrypt the message as long as the participants know the key that is used to encrypt it. There's
still problems with that, though, because people could add an input to the transaction and never sign it, and then everybody needs to, restructure the transaction until everybody finally agrees.
Yeah, the coin shuffle paper, I've had some conversations with the author of that paper. It includes a mechanism for basically finding out who the misbehaving parties are and booting them out. But yeah, that does increase the amount of time it takes to complete a transaction.
So all these applications are mainly wallet to wallet, right? This isn't something that I would use to send you a text message.
No, although you could do that too. If the communication channel is there, if you need to send the message from one wallet to another. I've had some conversations about this. Not a lot of people, encrypted messaging, it's, been around for a while. Still not a lot of people use it. So you can, maybe imagine if people can send encrypted messages from their wallets, maybe they would be more likely to use it in the future. So that's one possible application.
Besides sending private payments directly to a merchant, and we've got CoinJoin, what else can we use this for?
I'm talking with Manfred. He still hasn't had anything finalized with BitSquare, but he's working on creating a peer-to-peer order book for his exchange. So, I've had some conversations with him. You could certainly do something like a peer-to-peer order book using this type of protocol. I'm probably going to use it for communication. One of the kind of apps I've developed was I called it Bitcoin Authenticator. It was an Android app that provides a two-factor authentication for Bitcoin wallet. And I had a little alpha wallet that we wrote to go along with it. But one of the downsides with that was the wallet needed to basically take incoming connections from the Android app. And of course, people found that kind of difficult to do. UPnP doesn't work that well. So using something like this, we can just make, outgoing connections to Subspace network, both the wallet and the Android app, and kind of get around that NAT traversal issue that way and still have kind of a peer-to-peer connection between the two. So, that's an option.
And in fact, any type of multi-sig use case, this could help, because all the multi-sigs out there, like Copay or your Authenticator, or even OpenBazaar, everybody needs to find a way to get all the parties the transaction to sign. So this is kind of a cool decentralized way to accomplish that, right?
Yeah, exactly. So, if you start thinking about all the different things that you can do, if you had this network where wallets are all kind of using the same protocol, there's quite a few good things that you can enable. And I'm sure there's quite a few that haven't even thought of yet.
Well, this is all sounding very cool, Chris. So how far along are you? What works, and what's next?
I'm probably maybe 80% of the way done building what would be a beta version. I should have this done in a few weeks. I don't expect it to take a whole lot longer, although kind of be starting a new job in a couple of weeks. So I'm not sure how much time I'm going to have coming right up. But sometime within the next month or so, I should have a beta version. My plan is I've been working kind of on the side on a Bitcoin wallet as well. And so my goal is sometime later this year, I'm not exactly sure when, I'll probably release a wallet that uses this. And so people can kind of get their hands on it and see the different things that you can do with it. And maybe other people might want to give some feedback at that point. Maybe other wallets might want to use it. But sort of between now and then, which would be sometime later next year, I'm kind of going to use that as sort of the beta testing period, just to kind of iron out all the bugs and making sure it works right. And so sometime next year or later this year, I'll have kind of a production ready version out there. And then hopefully in the interim, if there are people who are interested in the project who have ideas for how to make the protocol better, I'm certainly open to that. As I said before, these sort of things, they only kind of become successful if there's community support behind it.
What language are you using?
Most of it, or all of it, is written in Python, but for the wallet, I'm probably going to write a small implementation in Java.
So you're looking for collaborators who know Python and Java to join you and help make this thing work?
Yeah.
you have a website or a GitHub? What's the best way to keep up with you?
This project, probably GitHub is best. My GitHub is just C. Pacia, first initial and last name.
Chris Pacia, thanks so much for your time today.
Thank you.
Thanks for listening to this episode of Let's Talk Bitcoin. Content for today's episode was provided by Matthew and Chris. Music for this episode was provided by Jared Rubens. This episode was edited by Matthew Zipkin. The magic word for episode 218 is COMM. That's COMM. You've got until about 10 a.m. Pacific time on June the 9th to visit letstalkbitcoin.com or the Let's Talk Bitcoin iOS app to enter it for your share of the listener rewards. Thanks for listening.